To make it more convenient to use, SPL can also be embedded as a plugin in Excel. After installing the plugin SPL XLL, you can call SPL function in Excel. In this unit, we will introduce how to install and use this plugin, and how to solve some common problems. Section 1. Installation and configuration. 1. Environment. First, check the installation environment. It is required that both Windows and Excel are 64-bit version, not 32-bit, otherwise an exception will occur. The method to determine whether Windows and Excel are 64-bit version is that, for Windows, click Settings, System, About, to find the information. For Excel, open Excel and click File, Account, About Excel. A pop-up dialog box will display the current Excel version. Note that you should make sure the SPROC version you are installing has the same language as your operating system. That is, install an English version SPROC if you are using an English version OS, and a Chinese version SPROC if your OS is Chinese version, otherwise problems like messy code will occur. If messy code or other problems occur after installing the SPROC with the same language as your OS, check OS configurations in Settings, Time Language, Administrative Language Settings, change System Locale. Check whether the current selected language is the same as that of the installed SPROC. If not, change it accordingly. 2. Installation. Start the SPROC as administrator, click Tool, Automatically Install Excel Plugins. After that, a message will appear on the screen, indicating that the Excel plugin has been installed successfully. If this message does not appear, you can find the reason by clicking Output in the right bottom of the SPROC. Generally, if you do not start SPROC as administrator, the installation will fail. The SPL function will be added to Excel after loading successfully. 3. Configure SPROC main path. To configure the SPROC main path, the script file to be invoked, i.e., .splx, should be placed in the target directory in advance, otherwise the search will fail. But in most cases, we will write the code in Excel cell instead of invoking a script, so there is no need to configure the main path. To set the main path, open SPROC, click Tool, Options, and select Environment to find main path. It should be noted that after configuring the main path, you need to restart the SPROC and Excel to make the configuration come into effect. 4. Logs. You can view exceptions in the log file. The file's path is appdata_sproc_tmp_excel.log. Section 2. Using SPL function. Once the plugin is installed and configured, the SPL function will be available in Excel for executing the SPL code in Excel cell and obtaining the calculated result set. The parameter format of SPL function is SPL, expression, arg1, arg2, etc., where expression is an expression string in SPL syntax, starting with equals sign. In the string, the question mark is used to represent the reference parameter, question mark 1 corresponds to the first parameter, and question mark 2 corresponds to the second one, and so on. arg1, arg2, etc., is the parameter value. There can be none or multiple parameters, 30 at most. You can fill in the constants or reference the current Excel cell, a single cell or a range of cells are allowed. The SPL function may return a single value, a row of values, a column of values, or a range of cells of values, that is, multiple rows and multiple columns. Here are some examples. 1. No parameters. For example, to generate random integers within 100, the writing method using SPL function is equals SPL double quotation marks equals rand 100, which only contains an expression string in SPL syntax starting with equals sign and no arg parameter. 2. A single parameter. In the following Excel file, the first column is the range of random integers, and the second column is the number of the integers randomly generated according to the range given in the first column. The question mark here represents the parameter A2 to be passed in. A2 has a value of 100, which means it will return a random integer within 100. Then dragging B2 down to every relevant cell can complete the calculation for the whole column. 3. Multiple parameters. In the following Excel file, the RGBA represent the red, green, blue, and transparency component respectively. Now we want to add a column on the right to compute the color value combined by the color components of each row. Enter the SPL code. In this code, $1, $2, $3, $4 respectively corresponds to the first parameter A2, the second parameter B2, the third parameter C2, and the fourth parameter D2. After entering the expression, the color value of the current row can be calculated. Then drag E2 down to every relevant cell to obtain all results. 4. A single row range parameter. According to the following Excel file, we want to calculate the median of each row after removing the largest value and the smallest value in each row, and then fill the result in the rightmost column. Enter this SPL code in I2. The parameter passed in here is no longer a single value, but a single row range parameter. Excel will pass the array combined by the range of cells A2 to H2 to SPL expression to replace the parameter question mark in it. It should be noted that Excel will automatically convert the array parameter to a two-dimensional array, even if there is actually only one row or one column. Therefore, there is a need to use conjunction function in the SPL script to concatenate into a single layer sequence, then sort it. After that, remove the largest and the smallest values and calculate the median. In addition to the conjunction function, you can use the e@1 function to convert it to a single layer sequence. The function e@1 can convert a single value or a two-layer sequence to a single layer sequence. A similar function is e@2, which can convert a single value to a two-layer sequence. Interested readers can refer to the function document themselves, and no further examples will be provided here. Finally, dragging I2 down to every relevant row can automatically compute the median of every row. Similarly, you can also pass in a column of data as parameter. For example, calculate the median of each column after removing the largest value and the smallest value in each column, and then fill the result in the bottom row. Like a single row range parameter, a single column range parameter will also be converted to a two-dimensional array, and it needs to use the conjunction function or e@1 function to concatenate into a single layer sequence. Then, dragging B14 right to every relevant column can automatically compute the median of every column on the right. Similarly, there is also multi-row, multi-column range parameter. According to the following Excel file, we want to add a column on the right to calculate the cumulative average of sampling data. That is, for the row of the first day, compute the average of the first day, for the row of the second day, compute the average of the first 2 days, for the records of the third day, compute the average of the first 3 days, and so on. Likewise, we remove the largest and the smallest values before computing the average. Enter this expression in Z3 to get the result 5.40. As can be seen from the expression that the parameter passed in is $B$3:Y3, where the first cell B3 is added with two symbols $. The reason is that we should always keep accumulating from cell B3 when copying the expression down, since what we want to calculate is the cumulative average. Drag Z3 down to every relevant row to get the cumulative average of every row. In multi-row, multi-column range parameter, it is common to see table with field name. For example, according to the following employee salary table, find the employee with the highest salary in each department. By directly passing in the range of cells A1 to D13, and then using the e function to convert it to a table sequence, you can directly reference the field name to perform calculation. Sometimes a table has no field name or does not need the field name. In such cases, you can use the e@b function to make a conversion, which will automatically generate the field names such as _1, _2. For example, this code is modified to use e@b function, and the field names of returned result are _1, _2, and so on. Note that the passed-in parameter area also does not contain field names. 7. Mixed parameters. The following Excel file contains the sampling data per hour for each day. Now we want to add a column on the right to calculate the average of the largest n values in all sampling data of this month as of the current day, and n is determined by the data in column Z. Enter this SPL expression in AA3. The content enclosed in double quotes is the SPL expression, which means that the top n values are calculated for parameter $1, and n is determined by parameter $2, then calculate the average of top n values. $B$3:Y3 is the parameter passed to SPL expression and corresponds to $1. Z3 is the parameter passed to SPL expression and corresponds to question mark 2. Drag AA3 down to every relevant row to get the result, as shown in the figure. 8. Double quotation marks exist in expression. Concatenate the string, hello, to the front of the string in column A to get the result in column B. SPL provides a simple writing method, equals double quotation marks hello slash A1 is okay. However, when the statement itself in a plugin function contains double quotation marks, they need to be escaped according to the Excel rule by writing a pair of double quotation marks as two pairs of double quotation marks. Alternatively, you can use $square brackets instead of double quotation marks, and the returned result will be the same. 9. Date. Column A contains a set of date data. Now we want to get the first day of the week in which each date falls. For example, June 1, 2024 is a Saturday, and the first day of the week it belongs to is May 26, 2024. This task can be accomplished directly with the pdate function of SPL. But if you code like this, an error will occur. The reason is that Excel and SPL use different base times. Excel takes January 1, 1900 as its base time, while most programming languages like SPL use January 1, 1970 as base time. Therefore, you need to use the function to make a conversion, and then you can get the correct result. Careful readers may find that the format of the results calculated in column B is different from that in column A. Column A contains dates, aligned to the right, while column B contains texts, aligned to the left. If you want column B to output date format, you need to use the function again to convert it back to the Excel date format. 10. Concatenate SPL expression dynamically. According to the following Excel file, add a column on the right to compute the cumulative aggregate of sampling data. The aggregate function is determined by the function name given in column Z. If it is median, compute the median. If it is average, compute the average. If it is sum, compute the sum, and so on. Enter this expression in AA3, where and Z3 an is a dynamically concatenated SPL expression, indicating that the content of Z3 is calculated. The parameter $B$3:Y3 is the same as in the previous example 6, we won't elaborate here. Having understood the various parameter types of the SPL function, let's take a look at its return value. The SPL function may return a single value, a row of values, a column of values, or a range of cells of values, multi-row, multi-column. For the example of removing the largest value and the smallest value from each row and then calculating the median mentioned earlier, the code provided is like this. It returns a single value, so dragging the formula is needed to get all results. Actually, you can also return a column of data to directly calculate out the results of all rows. The method is simple. First, pass in all the data to be calculated, and then use a loop function to perform the calculation. This is the returned result, which is a single-layer sequence in SPL and will be displayed as a column of values in Excel. It should be noted that when the return value is a column, you need to press Ctrl-Enter to return the result, and the result will be displayed as a column starting from the current cell. Seeing this, careful readers may ask, is there a method to display the results as one row? Yes, we will talk about it later. Let's continue with this example. Now we want to add a requirement. After removing the largest value and the smallest value, calculate the average in addition to calculating the median, and then fill the results in the two rightmost columns. For this task, it needs to return a range of cells of values. The code is not difficult to write either, and you can still use the loop function. It only needs to calculate an additional average in the loop function, and put the average result into a sequence together with the median result. The returned result is a two-layer sequence in SPL, and will be displayed as a range of cells of values in Excel, that is, multiple rows and columns of data, as shown in the figure. Similarly, when the returned result is a two-layer sequence, it also needs to press Ctrl-Enter to return the result, and the result will be filled rightward and downward into a range of cells, starting from the current cell. Similarly, the return value of the previous example of finding the employees with the highest salary in each department is also a range of cells of values. But it is a table with fields, i.e., the table sequence. Likewise, you need to press Ctrl-Enter to return the result. Now, let's talk about how to display the result as one row. Let's see the example of calculating the median of each column after removing the largest value and the smallest value in each column. The code provided in the original example will also return a single value, and it needs to drag the formula to get all results. Now we modify the code to directly return a row of results. Likewise, we can use the loop function and just need to return the result as a two-layer sequence with only one member, such as this sequence, which will be displayed as one row in Excel. Let's summarize the return value of SPL function. When the result is a single value, the operation of returning the result is the same as Excel rule. You can press enter or do nothing. When the result has multiple values, such as a row of values, a column of values, or a range of cells of values, you need to press Ctrl Enter to return the result. When the returned result is one-dimensional, such as one-layer sequence, it will be displayed as a column. When the returned result is two-dimensional, such as two-layer sequence or table sequence, it will be displayed as a range of cells, that is, multi-row multi-column. When the returned result is a two-layer sequence with only one member, it will be displayed as one row, which is the special case of multi-row multi-column. Once you understand the parameter types and return value of SPL function, writing code becomes more flexible. In the previous examples, such as 2, 3, 6, 7, 10, all the codes are to return a single value. You can try to modify them to return multiple values. Section 3. Editing SPL code. For certain computations, the SPL expression may be very complex, even more than one line, which makes it inconvenient to edit directly in Excel. To solve this problem, SPROC provides the Excel copy-paste feature to copy the edited code to Excel. In this section, we will introduce the editing method for multi-line code. 1. Generate complex SPL script with SPROC. We have an Excel file. Now we want to add a row at the bottom to calculate the average of the sampling data for each hour in January. We would write one expression that can calculate the average of every cell in the new row without copying the expression to each cell. The calculation result is shown in the figure. In this example, it needs to take B2 to Y33 as the parameter. Open the SPROC and define the parameter. Note that the parameter name here must be B2:Y33, which is the same as the parameter passed from Excel. First, edit the script, calculate the average of every column, and convert the result to a single layer sequence and return. Note that in the SPL script, the Excel cell, or a range of cells, as parameter, is enclosed in single quotation marks. Then, click Edit, Copy, Excel Copy. At this point, this code can be copied to the clipboard. Now, go back to the Excel file, select cell B34, and press Ctrl V to paste the code in, as shown in the figure. This code will return a one-dimensional array. Press Ctrl Enter to fill the returned array values right word into every cell of the row in sequence. In the above example, after the code is copied to Excel, we might close the SPROC and didn't save the code. In this case, if the code needs to be modified, it is inconvenient to modify it directly in Excel. To solve this problem, we can use the Excel paste feature of SPROC to copy SPL script back to SPROC for modifying. The specific method is as follows: select the whole SPL code in Excel, and press Ctrl-C to copy it to the clipboard. Then open SPROC and click Edit, Paste, Excel Paste. At this point, the original code can be restored to SPROC, as shown in this figure. 3. Extremely long SPL script. We have an employee.xlsx file as follows. The file must be stored under SPROC main path. We want to query the file to display the following columns only in the query result: EID, name, gender, depth, salary, birthday, hire date and state, and the display of column surname is not required. The query condition is shown in the right figure. In this example, the parameters to be passed to SPL script include B1, B2, D1, D2, F1, and F2. First, open the SPROC and define the parameters B1, B2, D1, D2, F1, and F2. Then write the script. Next, click Edit, Copy, Excel Copy to copy the code to clipboard. Now open the Excel file, select cell A4, and press Ctrl V to paste the code in, as shown in the figure. Due to the restriction on the length of string in Excel expression, extremely long code will be automatically split into multiple parts when it is copied to Excel, with each part not longer than 240 characters. If a part of code ends with a backslash, it indicates that the code has not ended, and the next parameter is still the code. Similarly, (1) to (6) correspond to the 6 parameters in the parameter settings respectively. After entering the above code, press Ctrl-Enter to return the query results. For longer SPL code, you can write the SPL script to a file and invoke it directly in the SPL function. The syntax format for invoking the script file is SPL parentheses, SPLX parentheses, arg1, arg2, etc. Where SPLX parentheses is the script file name without an extension. .splx will be added mandatorily, and must be followed by parentheses. If the script has parameters, it also needs to write (1), (2), etc. in the parentheses to indicate these parameters. arg1, arg2, etc. is the parameter required by corresponding to the script file in turn. You can reference a single Excel cell or a range of cells. A more colloquial way to express this syntax format is like this. The number of question marks to be written in parentheses depends on that of parameters in the script. The corresponding relationship rule with passed-in parameters is the same as that for directly writing code, that is, (1) represents the first parameter, (2) represents the second one, and so on. For example, in the above example, we save the SPL script file as example15.splx under sproc main path, and then write the expression in cell A4 of Excel. After entering the above code, press Ctrl-Enter to return the query results. Section 4. Using the clipboard. In many cases, we are more accustomed to debugging more complex codes in sproc, so sproc provides the clipboard function which can achieve data exchange between the sproc and the clipboard. For example, there is an Excel file, where column A contains the student names, and column B to D contain the scores in math, English and physics respectively. Now we want to find the top 3 students in score in each subject, and append their names to the end of score column of the corresponding subject. To achieve the objective, we need to use some features such as the rowset top n, join by sequence number. To make it easy, we use the clipboard. 1. Select the source data area A1 to D10 in Excel, and then press Ctrl-C to copy it to System Clipboard. 2. Open the sproc to write and execute the following script. A1, read the data from clipboard. A2 to A4, calculate the names of top 3 students in each subject. A5, join the names of these students to form a 2-dimensional table and convert it to a string. A6, write the result to clipboard. In this code, the clipboard function is used in 2 ways. When it is called without parameter, the string in the clipboard will be taken out, such as the cell A1. When it is called using a variable or cell name as the parameter, the string will be written to the clipboard, such as the clipboard A5 in A6. 3. After executing the above script, select the cell B11 in Excel, and press Ctrl-V to copy the data from clipboard to B11 to D13. When editing and debugging the script, it is very likely to use the copy and paste functions, which will overwrite the content in the clipboard. Consequently, the returned content will be the last copied code rather than the source data in Excel while executing the clipboard function the next time. In this case, the calculation will fail, and you have to go back to Excel to recopy the data, which will give you some trouble. To solve this problem, SPL provides the clipboard at E function, where the option at E means that it will always return the data copied from Excel for the first time to the clipboard. Let's have a try. In the example on the previous slide, suppose that we have copied the data from Excel and written the script. At this point, if we edit the script, and cut A3 and A4 and paste them into B2 and B3, A2 will report an error when the script is executed again, because the clipboard function in A1 gets wrong data. To avoid this problem, we need to modify the code, and use the just mentioned clipboard at E function in A1. By doing so, the script will still be executed normally after moving the code. The clipboard function can only return one result, but some complex operations may need to return multiple results. What should we do? We can directly copy multiple cell values, or variable values, in the result display panel of sproc to the clipboard separately, and return them to Excel in turn. Let's still take the student score table as an example and make the calculation objective a bit more complex. Append the names of the top 3 students in each subject to the end of corresponding subject based on the student score table, and add a new column, target, to calculate out 3 students for everyone, and each of the 3 students has a total score higher than and is close to the one to be calculated, as his or her target to surpass. Note that not all students have 3 targets, and the target students should be concatenated by the greater than sign. 1. Select the source data area, A1 to D10, in Excel, and press Ctrl+C to copy to System's clipboard. 2. Open the SPROC to write and execute the following script. A1. Get the data from clipboard. A3. Data area 1. Get the names of top 3 students in each subject. A4. Calculate the total score of each student. A5. Calculate the 3 students whose total score is higher than the one to be calculated. A6. Data area 2. Calculate 3 students whose total score is close to the one to be calculated. A3 stores the result data area 1, that is, the top 3 students in score in each subject. A6 stores the result data area 2, i.e., the targets of each student to surpass. It should be noted that export function and clipboard function are not needed in the code. Now we return the results to Excel. 3. Click on the data area 1, and click the corresponding Copy Data button on the right, as shown in the figure. Then, select the cell B11 in Excel, and press Ctrl+V to copy the data area 1 to B11 to D13. 4. Click on the data area 2 in the script, and hold down the Shift key and click the corresponding Copy Data button on the right. After that, select the cell E1 in Excel, and press Ctrl+V to paste the data area 2 together with the column name to E1 to D10. Note that we can use Shift key to control whether the calculation result has a column name. Having solved the multiple target problem, it is easy to think of the multiple source problem. In practice, the calculation may need to use multiple source data areas in Excel. However, the clipboard function only holds the most recently copied data area. How to solve this problem? We can copy the clipboard content directly into a cell in the cell set. For example, there are 2 sheets in Excel, order details and employee list. Calculation objective: query the order data in the last days, or the order data belonging to the department list depths. The required columns include the order ID, order date and amount in the order details, and the name and depth in the employee list. In these conditions, days is an external parameter, and you can enter a different value for each execution. For example, entering 30 means querying the order data in the last 30 days. Depths is also an external parameter, such as marketing, finance. First, select the data area of order details sheet in Excel, and copy and paste it to the cell A1 in SPL cell set together with the column names. Likewise, copy the data area of employee list sheet to cell A2 in SPL cell set. Note that the paste action should be performed when the cell A1 is in the editing state, otherwise the content of the clipboard will be filled into a large range of cells, as shown in this figure. This figure shows a wrong result. Since it occupies a too large area, the code layout will be affected. If the operation is correct, only a small part of data is displayed on the appearance of cell A1 or A2, and the complete data will be presented only when clicking A1 or A2. This is the unique feature of cell style code, which is suitable for copying a large range of data without affecting reading and code layout. 2. After copying the 2 source data areas, edit the script, during which we can run the script many times and perform the copy and paste actions manually. 3. After the calculation is finished, we can use the Copy Data button to copy the calculation result in A5 back to Excel. It should be noted that the data in the cell A1 or A2 should be cleared when saving the code, otherwise all source data will be saved.